Why deep-sea creatures hold the key to life beyond Earth. There is a place on Earth where the sun has never shone. No sunrise, no warmth, no color, only darkness, pressure, and time. For most of human history, this world was believed to be empty, a vast, lifeless abyss beneath the oceans, a place where nothing could survive. We were wrong. Far below the surface, deeper than light can reach. Life exists in forms so strange that they challenge our understanding of biology itself. Creatures that do not depend on sunlight. Creatures that thrive under pressures that would crush steel. Creatures that live in environments poisoned by chemicals once thought incompatible with life. These are not accidents of evolution. They are survivors. And today scientists believe these organisms may hold the most important clues yet to life beyond Earth. To understand why, we must begin with the simple truth. Life, as we know it, should not exist without energy. On the surface of our planet, nearly all ecosystems are powered by the sun. Plants capture sunlight through photosynthesis. Animals feed on plants or on other animals that do. The energy flows in a predictable chain from light to life. Remove the sun and the system collapses. At least that was the assumption. But deep beneath the oceans, that rule breaks. At depths beyond 1,000 meters, sunlight vanishes completely. The ocean becomes black, not dark, but black. A darkness so complete that vision loses meaning. And yet, life continues. In this world, organisms have evolved an entirely different strategy. They do not rely on light, they rely on chemistry. Along fractures in Earth's crust, deep beneath the seafloor, superheated water erupts into the ocean. These hydrothermal vents release clouds of minerals, metals, and toxic gases, including hydrogen sulfide. To most life, these chemicals are deadly. But here they are food. Bacteria living near these vents convert chemical energy into biological energy through a process called chemosynthesis. Instead of using sunlight, they use chemical reactions to survive. These bacteria form the foundation of an ecosystem unlike any other on Earth. Giant tube worms with no mouths and no digestive system survive by hosting these bacteria inside their bodies. Crabs, shrimp, and fish gather around vents, feeding on organisms that should not exist in the first place. Life, it turns out, does not need the sun, it needs energy. In any form it can find, this discovery changed everything. Because if life can thrive in the darkest, most extreme environment on Earth, then Earth may not be unique. Far from our planet, in the cold outer regions of the solar system, lie worlds that were once dismissed as frozen, dead, and irrelevant. Moons covered in ice. Places too far from the sun to support life. But beneath their icy shells, scientists now believe oceans exist. Vast oceans on Jupiter's moon Europa, a global ocean may lie beneath kilometers of ice. On Saturn's moon Enceladus, geysers of water erupt into space, carrying organic molecules with them. These oceans are dark, cold, and isolated from sunlight, just like Earth's deep sea. And if these oceans touch rock below, as Earth's oceans do, then hydrothermal activity may be possible there as well. The same chemical reactions, the same energy sources, the same conditions that allow life to exist in Earth's abyss. Suddenly, the question is no longer whether life needs sunlight. The question is whether life needs Earth at all. Deep-sea creatures show us that evolution can take radically different paths. In total darkness, eyes become useless. Some species lose them entirely. Others develop enormous, ultra-sensitive eyes, capable of detecting the faintest glimmer of bioluminescence. Bioluminescence itself becomes a language. In the deep light is communication. It is camouflage. It is hunting. It is warning. Creatures flash patterns to confuse predators. Others use glowing lures to attract prey. Some emit soft blue light simply to disappear, matching the faint glow from above. This is not random chaos. It is adaptation under pressure, extreme pressure. At depths of several kilometers, the weight of the ocean above can exceed 1,000 times the pressure at the surface. Human bodies would be crushed instantly. Submarines must be engineered to survive. Yet deep-sea organisms flourish. Their proteins are structured differently. Their cell membranes are more flexible. Their chemistry is fine-tuned to conditions that seem impossible. This tells us something critical. Life is not fragile. It is adaptable. If biology can reshape itself to survive crushing pressure, toxic chemicals, and eternal darkness, then environments once thought hostile may actually be habitable. Not comfortable, not familiar, but alive. And this changes how we search for life beyond Earth. For decades, scientists focused on planets like our own, rocky worlds in the so-called habitable zone, where liquid water could exist on the surface. Places where sunlight and Earth-like conditions might allow familiar life to emerge. But deep-sea life teaches us that this approach may be too narrow. Life does not need Earth-like conditions, it needs opportunity. Energy gradients, liquid water, chemistry in the deep ocean. Life exploits every crack, every chemical imbalance, every chance to survive. It adapts, evolves, and persists in places that defy intuition. On Europa or Enceladus, similar opportunities may exist. An ocean locked beneath ice. Heat generated by tidal forces. Chemical reactions between water and rock. To life, this may be enough. And if life does exist there, it may not resemble anything we know on the surface of Earth. It may resemble the abyss instead, slow-growing, chemically driven, invisible to light, perhaps microbial, perhaps complex, perhaps something entirely new. Deep-sea exploration also forces us to confront a humbling reality. We have explored more of the Moon and Mars than we have of our own ocean depths. Vast regions of Earth remain unobserved, unmapped, and unknown. New species are discovered every year, many of them completely alien in appearance. This suggests that life's potential is far greater than we imagine. We are not experts on life in the universe. We are beginners. The abyss beneath our oceans is a testing ground, a natural laboratory where evolution experiments under the most extreme constraints. Every organism there is proof that life can emerge, adapt, and endure in places we once dismissed as impossible. And if that is true here, then it may be true elsewhere. Perhaps life beyond Earth is not waiting under alien skies, breathing alien air. Perhaps it is hidden beneath ice, in darkness, in silence, waiting. The same way deep sea life waited for us to discover it. The key to finding life beyond Earth may not lie in looking outward alone, but in understanding what already lives beneath our feet, in the depths we once feared, in the darkness we once ignored. Because the universe may not be silent, it may simply be speaking from the deep.